Hello everyone, welcome to my channel Mathenthusiasm. Today we're going to evaluate the integral of secant x with the first 4 basic forms of the answer. Yes, here are another 4 advanced forms in the next video. First of all, there's no simple integration formula for us to use. Why not consider the derivative of secant x first? The secant x dx is equal to secant x times tangent x. We can see the friend of secant x, which is tangent x. They have a nice relationship. Secant square x is equal to 1 plus tangent square x. We shall use this square identity later on. So let's find the derivative of tangent x as well. The tangent x dx is equal to secant square x. Good, let's add them together. Then there's a common factor secant x on the right hand side. Take it out, we have secant x times bracket tangent x plus secant x. You can see that these two brackets are exactly the same. Let's call them u. So the equation is du dx is equal to secant x times u. Now we put the u terms on the left and x terms on the right. Integrate both sides, we get integrate 1 over u du is equal to integrate secant x dx. The left hand side can be evaluated. It's simply log absolute u plus c. From now on, throughout the whole video, c is a constant. We put the expression of u in terms of x. The answer is log absolute secant x plus tangent x plus c. That's the first form of the answer. Perhaps you have come across the magic substitution u equals to secant x plus tangent x, but you may not know where it comes from. This is the simplest way to understand it. So what about the other 3 basic forms? We need an important result for the other 3 forms. That's integrate 1 over 1 minus u squared du. It will be used frequently. First of all, the denominator is the difference of 2 squares. We can factorize it into bracket 1 plus u times bracket 1 minus u. Then we multiply 2 and divide 2 at the same time. It helps us split the integral into 2. Yes, it's the partial fractions. Now, the 2 in the numerator can be written as bracket 1 minus u plus bracket 1 plus u. So we can change the integrand into 2 simpler ones, 1 over 1 plus u plus 1 over 1 minus u. Further separate the integral into 2, and then we change the differentials into 1 plus u and 1 minus u respectively. Now, the answer is 1 over 2 log absolute 1 plus u minus log absolute 1 minus u plus c. The difference of 2 log terms can be combined as a single one. It's 1 over 2 log absolute 1 plus u over 1 minus u plus c. So how do the other 3 forms of answer depend on this result? Let's write secant x as 1 over cosine x. Multiply both numerator and denominator by cosine x. Then the term cosine square x can be changed to 1 minus sine square x. Now, it's good to do the substitution. Let u equals to sine x, therefore du is equal to cosine x dx. So the integral is just integrate 1 over 1 minus u squared du. Great, we got the result of this integral already. Let's put it back. Now, we put u equals to sine x into the answer. We have 1 over 2 log absolute 1 plus sine x over 1 minus sine x plus c. Because sine x is smaller than or equal to 1, and for the denominator 1 minus sine x to be non-zero, sine x cannot be 1. Putting these two together, we have sine x is strictly smaller than 1. Let's focus on the numerator 1 plus sine x and the denominator 1 minus sine x. Because sine x is smaller than 1, therefore both of them are positive. So the absolute sign is not necessary. The second form of the answer is 1 over 2 log bracket 1 plus sine x all over 1 minus sine x plus c. Next, we come to the third one. Still writing secant x as 1 over cosine x, then we're going to use the classic half angle substitution. let u equals to tangent x over 2. Differentiate both sides, we get du is equal to secant square x over 2 times 1 over 2 dx. Using the square identity, secant square x over 2 is equal to 1 plus tangent square x over 2. We put these terms to the left, then dx is equal to 2 over 1 plus u squared du. Alright, the differential is ready. How about the integrand 1 over cosine x? We have to express it in terms of the half angle x over 2 as well. Because cosine x is equal to 2 cosine square x over 2 minus 1, change the term cosine square x over 2 to 1 over secant square x over 2. Again, we can use the square identity to relate it with tangent x over 2. So it's equal to 2 over 1 plus u squared minus 1. Combine the two terms together, we get 1 minus u squared over 1 plus u squared. Now, we can put everything into the integral. Therefore, integrate secant x dx is equal to integrate 1 over bracket 1 minus u squared over 1 plus u squared times 2 over 1 plus u squared du. Cancel out the term 1 plus u squared, then we get the form integrate 2 over 1 minus u squared du. Apply the result, we have 2 times 1 over 2 log absolute 1 plus u over 1 minus u plus c. Cancel out the 2 and put back u equals to tangent x over 2. Then the answer is log absolute 1 plus tangent x over 2 all over 1 minus tangent x over 2 plus c. We can make use of this result to get the fourth form of the answer. It involves a special property of tangent x. Let's look at the compound angle formula. Tangent bracket a plus b is equal to tangent a plus tangent b all over 1 minus tangent a tangent b. We have a plus sign in the numerator and a minus sign in the denominator. The formula and the answer look pretty much alike. Comparing these two, if we put b equals to x over 2 and tangent a equals to 1, that is, a is equal to power 4, then we get it. In other words, the fraction can be changed to a single term, tangent a plus b. So the fourth form of the integral is log absolute tangent bracket x over 2 plus pi over 4 plus c. Okay, these are the 4 basic forms of the answer. What about the other 4 advanced forms? You may want to check out that video in the playlist Calculus in my channel. The link is in the screen and in the descriptions below. See you in the next video.